Bless you. All right, here we go. Congruence. When things are congruent, then through a series of rigid motions, one thing transfers on to the other. Okay? So if we take this one, move it this way, and move it down to this way, actually we flip it over a line of reflection and then move it down this way. These figures are the same shape and the same size, so then they're congruent. So anytime you can do rigid motions to make two things the same, then they're congruent. So two figures are congruent if the rigid motions map one onto the other. It's called a congruence transformation if you can do that. Now, to be congruent, every angle must have a corresponding congruent angle. And every side must have a corresponding congruent side. Okay? Now, what's important here is the order of the letters. A is congruent to D, so A and D have to be in the same order with B and E and C and F. So A goes with D, B goes with E, C goes with F in that order. You cannot switch up the order. Okay? So if we said angle PQR is congruent to triangle MTS, that means angle P is congruent to angle M. Angle Q is congruent to angle T. And angle R is congruent to angle S. Okay? Side PQ would be congruent to side MT. Side QR would be congruent to side TS. And side PR would be congruent to side MS. The letters are important. Okay? The order of the letters are so important here. So, if they say XYZ and ABC, X and A must be congruent to each other. Well, guess what? They're both what types of angles? Right angles. And then Y and B would be together, and Z and C would be together. So what rigid motions makes this go to this? Well, what's one thing that we could possibly do? Are they in the same relative position where Y is on top? Is B on top? No, B is on the bottom. So it's a reflection of some sort, right? So we need to reflect somehow. So if we reflect down like this, so if we reflect across the line, Y equals 2. Then we have X, Z, and Y here. Well, that looks pretty good. Okay? But then we want this straight part, X and Y, to be where A and B is. So we now have to reflect it across here. So if we reflect it across the Y-axis, this is 2 away. So 2 away would be there. This is 6 away. So 6 away would be here. This is 6 away. So 6 away would be here. So then if we reflect across the line X equals 0, because X equals 0 is the Y-axis, it would look like this. Then I need a third transformation, which is a translation. The green one has to go one that direction. What's one that direction? -1, 0. So that's everything involved. Now, could I have shortened that up by 1 step? Yep. I could have reflected that around the line Y equals 2, and then gone halfway in between this point and this point. What's halfway in between 1 and -2? -1/2. So I could have reflected around the line X equals -1/2. and got it done just like that. Both of them are legal answers. B is on top, B prime's on top. All this is a translation. What type of translation is it? One to the right, -4 down. Which triangles are congruent? Now, you got to look here. From B to C, we go up 1 over 3. From F to G, we go up 2 over 3. Would they be congruent? No. So, because we have a straight up and down part on FE and no straight up and down parts there, these two are not congruent to each other. Cannot be. Okay? Straight up and down part, any straight up and down part here? No. So these two can't be congruent to each other. So the only two that could be congruent are this one and this one. So let's see what happens. Up 1 over 3, up 1 over 3. If we go up 1 over 3, up 1 over 3, their distances are going to be the same for this and this. So we know those are the same. So let's look at other parts of that triangle. For J to K, I go up 1, 2, 3, 4, and over 1. Up 1, 2, 3, 4, and over 1. Hey, that's the same. So this is congruent to this. So let's see if the long parts are congruent. From A to C, I go 1, 2, 3, 4 over, and 1, 2, 3, 4, 5 up. 1, 2, 3, 4 over. 1, 2, 3, 4, 5 up. That works. So triangle ABC is congruent to what triangle? Now we got to get letters in the right order. A to B to C, like that. So it has to be JKL. It happens to go in the same alphabetical order. Are these two congruent? A and E are the same. The distance to get from A to B and A prime to B prime are the same. The distance to get to B to C and B prime to B prime are the same. C to D, C prime, D prime are the same. And E to D and E to D are the same. So if they're all the same, the answer is yes, they are congruent. Are these congruent? Do they look congruent? Yes, it's a what to get from here to here? A reflection across a vertical line like this. Okay? A boat builder plans to connect two pieces of a boat with a joint like this. Okay? Now, if we can move, I can't scroll, so we'll go like this. These two have to be congruent. Do they look congruent? Yes. What type of rigid motion is it? Translation. Okay? So anytime things are congruent, they're rigid motions. This is a reflection. You could use a translation. You could use a rotation. You could use a combination of them called the composition of transformations. Okay? So that's your first assignment. We'll work on 2 today. 1 before lunch, 1 after lunch.